Difficult to read because when there is the sun outside, sometimes there is some reflection on the blackboard. It's difficult to read, so I will try to do my best, but sometimes it's not easy for me to get a picture of the situation. So as I said, for hydrology, we will focus on the issues that are most related to water resources management. And what is water resources management? Is a relatively young field, because water resources management, as we will see later, was brought to the attention of society not before than the 70s. It was around the 60s of the past century, so about 1960, 1970, that people realized after the economical increase that followed the Second World War, they realized that water was becoming a problem in the modern society. Water was not a problem before. Before than that, it was mainly, there were some water problems, but mainly related to floods or in some specific location to pollution. But the quantity of water supply in the civilized societies was not a problem until 1960, 1970. Maybe it was a problem in developing countries, but for instance in Italy, in Europe, and in the United States, it was not a problem to find the amount of water that was needed for people. Around 1960, 1970, people started to realize that water was becoming a problem. And let me make a comparison with the air. Air, for us, is not a problem. We think that we have an unlimited quantity of air to breathe. And it was a similar situation for water in the European countries, civilized countries, and the United States until 1960-70. They believed that there was plenty of water, all what was needed. As a consequence, water was not considered an economic good. People were used to pay some fees for getting water in the houses, but the fees were very much reduced. The water was managed by public entities, and basically it was not considered an economic good. Starting from that time, as we will see with more details, 1960-70, then people started to realize that water was not unlimited, and consequently, some people tried to introduce the concept that water was to be considered as an economic good. And it was not easy to accept this concept, because you wouldn't be willing to consider that the air to breathe is an economic good that you have to pay for it. So it was really a concept that was difficult to introduce and to accept. But on the other hand, when you have a vital element like water that becomes scarce, you have to introduce the concept to treat it as an economic good. Otherwise, people don't save it. So, water resources management is about solving problems to secure water. Secure water means, well, here I was saying, means to provide water to people. And of course, this is to be based on a sound scientific understanding of hydrology and hydraulic processes. We will provide a definition of hydrology later on. I think you don't need to be provided a definition for hydraulics, while maybe that you need a definition for hydrology. And of course, water resources management, in a broad sense, includes the protection against excess of water, meaning includes flood management. This is not traditional, meaning that traditionally water resources management is just about water supply. In the modern concept of water resources management, we tend to include protection against excess of water. We will not speak in detail about floods, but we will consider that floods, protection against floods, is a part of water resources management. So at the end of this class, I expect that you will be aware of the water resources issues at local scale, national and global scale. You will be able to qualitatively and quantitatively describe the main processes of the hydrological cycle. So you will learn about models to describe the water cycle. The hydrological cycle is basically like a synonym of the water cycle, which is important to describe because if you want to deal with water, you need to understand the hydrological cycle, the water cycle, and also you will be able to provide professional solutions for typical water resources problems and practical problems. This is what I expect. Of course, the course is just 60 hours, so my aim is to provide you an extended introduction by focusing on the most compelling problems at the local scale. And therefore, for instance, I will focus on the region where we are studying, the Emilia-Romagna region, because I want to focus on some specific problems to provide some more details. This is my program. And first of all, of course, introduction, definition, and quantification of the water of some problems. Illustration of a case study. I want to start with a case study, with a practical problem. It will be a lecture, probably next week, next Monday, which will be not really quantitative. It will be just a description, a qualitative description of the case study, but I want to start with a case study to make you aware of a practical problem and the need to solve this problem. Then, the next step is the assessment of water resources availability, and this is a big problem. The first problem that we have to solve, we have to know how much water is available, and this is not simple at all. You may think that this is simple. You may think that we just need to take some measurements. It's not like so. Measurements are difficult to take and also are difficult to model and to provide interpretations. Then I will pass to water resources management, which means basically taking decisions. When you have a limited amount of water, when you have to face a water resources management problem, it means that you don't have enough water to satisfy all the needs. Otherwise, you don't have any problem. You go back to the situation before the 60s. Today, we introduced the concept of water resources management because we don't have enough water to satisfy all the needs. And therefore, you need to take decisions. Like, I give water to this guy instead of the other one. And this involves a theory for taking decisions. Not because you can't avoid the theory. Many times, the decision to take is very evident. This is sometimes a drawback of water resources management. The solution is very clear. The problem is that you have to convince people that this is the right solution. So for the engineer, very often the solution is very clear. The problem is that sometimes you cannot take this solution because maybe it requires too much money, and especially you have to convince people. And this is the right solution. And to convince people, you need to prove that your decision was not subjective. It was scientifically based, and therefore you need to use decision theory. And also what is very much important, this is a concept which is fundamental, is the presence of uncertainty. We have to take professional decision, we have to make a kind of professional design in the presence of uncertainty, which is not for us a usual situation. When we design a building, when we design a structure, we have a very small uncertainty. When we analyze, for instance, the external forcing, when we make what we in Italian call the analisi dei carichi, the uncertainty is very small. And when we study the strength of a beam, like the tensions that a beam, a trave, can sustain, we have a little uncertainty. When we talk about hydrology, uncertainty is very much significant, very large. This is a big problem, because if you could quantify exactly, without error, how much water is available, it's easier for you to take a decision and convince people. The problem is that even if when you look to a river and you want to know what is the volume of water that during a year passes under a bridge, there is a huge uncertainty, very huge. You don't have a precise idea, and therefore you have to take a decision that is based on uncertain data. And to give you an idea, when we talk about river flow, if we get an estimate in the optimal situation that is erroneous by plus minus 20%, it's a good estimate. So this is to give you an idea. Plus minus 20% is a huge amount of uncertainty, which means that your decision could be completely wrong if you estimate that the amount of water is 100 and it turns out to be 80. The decision could be completely wrong. So uncertainty is a very important concept, and when you talk with people, you have to assume that people don't realize that there is uncertainty. They are convinced that you as a professional engineer, you can estimate how much water you have, you can say what is the dynamics of water without any error. While we don't know what happens when we dig a well and we start taking water from the underground. We see some water coming out, but if we had to make a prediction of how much water I can take out, it's impossible. There is a huge uncertainty. People don't realize this. So they just say, let's dig some wells and take the water that we need from the underground. They don't realize that the water in the underground may finish, and to predict this is very, very difficult. So this is the interesting part of hydrology and also the problem of hydrology, the main problem of hydrology. Much part of the research activity on hydrology that is done today is focusing on estimating uncertainty. And this is a big issue, very popular subfield of hydrology. And also there is climate change. Climate change, you know, it's an issue. We know that the media, everybody's talking about climate change. We need to be very careful. And you know, I won't speak much about climate change because it's an issue that, you know, it would require an entire separate course on climate change. But climate change, let just me say that you have to be very cautious, very prudent, because you know, it's not clear what is going to happen. Of course, climate is going to change. It's always changing. We had glacial periods. We had periods in which the glaciers were much more extended than today, and we had periods, even in the recent past, 500 years ago, in which the glaciers were much smaller than today. So there are huge changes in climate, either for natural and human-induced reasons. There are huge changes. To predict them is very, very difficult. Even if the media tend to tell you that they know for sure that in 15 years from now, climate will change in some way, which are very different. If you compare the prediction of climate change that were done 20 years ago, they are very different from the predictions that are done today for the same period, like 2050. 20 years ago, they said that the temperature was increasing by 10 degrees. Now they say 5 degrees, and very different. So it's very difficult to predict. So climate change is something that, you know, makes our job much more complicated. Let me see if we got some. Okay, this is the R website, and you will see here. Just let me make a parenthesis. Some nice graph. R is very powerful for drawing graphs. There is no comparison in the quality of the graphs that you can draw with R with Excel. No comparison at all. And I will show you some demonstration of graphs that I did. It's not easy to make graphs in R, but it's very much powerful. And the download is somewhere here. Let me go down. Download here. To download R, here you see. You have to click here, and then you get to the download side. I won't give you any detail now because it's very easy. A few words about documentation. There are a lot of manuals here available. I think there are also manuals in Italian, so you can for sure download one of them. If you want to take a manual, just wait for the first lecture, and then you can download some. I suggest you to download the smallest one that you can find, because there are many of them. And to start, you don't need much. Take the smallest one, okay? Because it's more efficient to start just from the basic information, and then we will learn together how to use it. Let me see if my website is still working, but it's not a big problem. Okay, here you have everything. You see, these are all the slides and the documents. Introduction to the course is the PowerPoint that I was using just, I'm using now. And I wanted to download this if it's possible, because, okay, here it is. I don't need it now, but later on I will need it. Okay, I think I give you back the phone. I don't need the connection anymore, thank you. Good. Now let me go back to my presentation. Okay, so this is basically the program for macro subjects. I will follow this timeline. Some information about myself, something we already discussed on. And, okay, but these are information that I didn't discuss. For explanations, for individual explanation, I prefer not to indicate fixed times when I can receive students, because you are just a few students, and I prefer to receive an appointment. And usually I'm able to receive you as soon as you ask me. And one solution could be after the lecture, you just stop me by and ask me for clarification. Not today, because today I'm stopping in half an hour from now because I have another commitment. And if you need an individual appointment, just send me an email. This is my email. And unfortunately or fortunately, I am checking my emails like 200 times a day. So usually I get your email as soon as you click on the send button. And if I don't reply, it's just because I don't know what to reply. But usually I reply in 5 minutes. So don't be concerned. I don't lose your email. Impossible, because you know, I'm focusing on the email and I try not to use the phone. So please, if you can avoid phoning me, it's much better for me. Even because it's not easy for me, for you to find me on the phone. Because when I took the chairmanship of the degree program, you know, I got so many phone calls that sometimes I turn it off. It's impossible for me to manage. So the website you already know. I didn't speak about final year projects. If you want to discuss with me the opportunity to make a thesis, it's no problem. We can do that. This is a textbook that I was mentioned to you before. Applied Hydrology by Vantage Road. The reason why I'm suggesting this book is I think it's a good book. And now about hydrology, about water resources management, I have no any news about books in print. About hydrology, many colleagues told me that they are in progress of writing books. So I guess that in a couple of years from now, maybe new books on hydrology will be made available. Because if I had to suggest a book today which is up to date in hydrology, I wouldn't give you any useful suggestion. I just would say wait a couple of years. Because hydrology is developing and, you know, this is 20 years old, it's a good book, but still it's outdated. But this is a good book because it's written from the perspective of an engineer. Keep in mind that hydrology is a physical science, we will see a definition. And at the international level, in Italy, hydrology is mainly dealt with by engineers. At the international level, it's dealt with by engineers, minority, geographers, and physicists in general. So it's a different perspective. If you see a book written by a geographer, I would not say that it's useless for an engineer, but it's completely different. And this is a book that is written by an engineer with a very engineeristic experience. So it deals with open channel flow, things that are important for the design. So I think it's a good book. Also, the price is not very relevant. It could be a good book for a library. I'm not suggesting you to buy it for this course. It's just, if you ask me what reference would you suggest, this one. But I'm not suggesting to buy it. So, water resources management. This is a classical picture that clarifies what is water resources management. And this is an introduction to the course. With this introduction, I want to clarify you what is water resources management, what is hydrology, and what are the main problems. So this is something that is difficult that I ask to the final examination. But it's an information that I think it is necessary for you to understand the subject. And I will try to make it more interesting as possible, as more interesting as possible. Of course, it's, you know, it's a bit a kind of notion, so I'm aware that it's not really interesting. But in any case, let's say that water resources management is composed by water supply management, water excess management, as I said, and environmental restoration. Let me focus on this concept. This is fundamental. And in the beginning, water resources management, as I said, was just about water supply. Then the concept was extended to flood protection because they are related, but was extended to environmental restoration because it was realized, we understood, that for water resources management is very much important to preserve the environment, which may seem a very obvious concept to you. It was not so obvious some years ago. If you think that the sanitation plant of Milan was built about 10 years ago, and until 10 years ago Milan was just releasing dirty water in the Lambro River without any sanitation, you understand that the concept is relatively young, the concept of environmental restoration. And you see here an important feature of water resources management. Water resources management is not just hydrology, it involves a lot of sciences. And in particular, let me put the accent on macro categories. Biological sciences related to environmental restoration and water quality. Water resources management is much water quality, because you don't need just water, you need good water, good quality water. So it's very much related to biological sciences. It's related to engineering, of course, because when you want to design the water supply plants, you have to, of course, refer to engineering. It's related to physical sciences. What is physical sciences? Physics is the science that studies the motion of matters, and therefore water is moving. So you have to refer to physics and social sciences. Social sciences is of paramount importance. I already mentioned to you that a big issue in water resources management is to convince people that the decision that you took is the right decision. And this is a social problem, communication problem. And I can tell you from my experience in consulting activities, I don't do any professional activity, but I do a lot of consultancy for the university. And when I speak with people, I can tell you, and with politicians, it's really a big problem. A big problem to explain. If you want to explain that climate change is relevant, but to what extent it is relevant, it's very difficult. You see people that think that climate change is the main issue. When I have to explain that climate change is not the main issue, it's one of the issues, but then there is water quality, there is urban planning, etc. They don't understand. For them, it's climate change and just climate change. So this is a big problem to convince people. How can you do that? How can you convince that climate change is as much as important as urbanization, for instance? So if you are not careful in urban planning, no matter of climate change, you have water problems. This is difficult to explain to people. And also you see that any macro group of sciences includes many others. And these are all related to water resources management. So it's important that we say already now that we are focusing on water resources management from the engineer's point of view and from the hydrologist's point of view. So we will not deal with social sciences. We will deal with decision theory, which is related to social sciences, but not really included. It's not really a social science, decision theory. So we will focus again